Hi, sixth graders. We are going to be taking another page of notes today, and we're kind of summarizing up everything that we've learned over the past couple of weeks. If you remember this image that we looked at that very first week, we have talked about now fractions going to decimals. We have now changed decimals into percents and vice versa. We have now gone from decimals and percents to fractions. And so we have translated back and forth and here to there. And so the last thing that we're going to do with all of these fractions, decimals, and percents is we are going to learn how to compare them and order them. So the title of this page is going to be Compare and Order Fractions, Decimals, and Percents. And if it's okay, I'm just going to call that FDP, Fractions, Decimals, and Percents. All right, so let's just look at some examples. And actually, let's say first that in order and compare, when we are ordering and comparing, we must have all numbers in the same language. Must have them in the same language, which means that if we have a fraction, a decimal, and percent, we're going to want them to be in the same language before we compare them. So let's think about an example that maybe you have already done somewhere, probably in elementary school. So let's say we have 0.46, 0.4, and 0.04. And we want to order from least to greatest. Order from least to greatest. Now you always want to make note of what it's asking you to order. So in this case, it's going to be least to greatest. You always want to make sure you make a note, least to greatest. Even if you do all the right work, you could do it greatest to least and miss the whole problem. So make sure you pay attention to what it's asking. So from least to greatest. And what we're going to do is we're going to line up. Now, all of these are already in the same language, right? We've got decimals. So we've got decimal, 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 all in the same language. We're going to line these up and we're going to compare them. So I'm going to line them up according to their place value. So we're going to line up the decimals. And so we've got 0.46, 0.4, and then we've got 0.04. Now, in order to compare these really well, we can fill in any blanks with zeros. So notice how this first one has 2 decimal places. This only has 1. This has 2. We could actually add a 0 here just to make it nice and even so we can compare. And if we want the least, what we're going to do is we're going to start here on the left. We're going to compare. Can we figure out which is the least? So we're going to start with these first numbers, 0, 0, 0. Well, out of 0, 0, and 0, which one's least? Well, they're all the same, right? So this number right here, starting again from left to right, the ones place does not help us make any determination. So we're going to move past the decimal over to the next line, and we're going to say, okay, out of these numbers, the second set of numbers here, can we figure out which one's least? And yeah, there's a 0 here, but these have 4. Well, out of 4 and 0, which one's least? This one's the least. So I'm going to put a little tiny number 1 next to this because it is the very least. It is the least number that I have. You could even actually write an L next to it if you wanted to, if you want to label it like that. So either 1 or L, this is going to be our least number. Now we're comparing these two. So they both have 4, so that doesn't help us, but we're going to move on to this last number. Again, we're moving left to right. Move on to this last number. Here we have a 6. Here we have a 0. Out of 6 and 0, which one is least? It's 0. So this is going to be my second in order, or we could call it the middle number. So the second in order, or we can say the middle. And then 6, of course, is going to be the greatest. So 0.46 is going to be the greatest out of this. This is either my third number, or I could say G for greatest. And so when I put them in order from least to greatest, I'm going to have 0.04 is going to come first, 0.40 is going to come second, and 0.46 is going to come last. And this is my answer. Now, that's how we're going to compare them if they're already in the same language. Now, of course, we're going to have some examples where maybe they're not in the same language. So let's look at a different example. So the next example, let's look at 2/5 and 17% and 0.7. And so we want to put these, we're going to order these. It's always going to tell you how to order them from greatest to least. Order from greatest to least. And so we look at our numbers here, and we of course notice that they are not in the same language right now. We've got a fraction, we've got a percent, and we've got a decimal. Now, we want them all in the same language, and just like we saw up here, it is really fairly easy to compare decimals. So what I'm going to do is I'm going to make sure that all of these numbers are decimals, and I'm going to line them up and compare them just like I did up here. So the first thing we have to work on is changing 2/5 into a decimal. Now, maybe you already know what 2/5 as a decimal is. If you have it memorized, awesome. You can write that down here. If you don't have it memorized, remember, how did we change fractions into decimals? Well, we have to divide. And so we put the top number inside, bottom number on the outside. 5 will not go into 2, so we have to add a decimal and a 0. 5 will go into 20. Make sure you put your decimal up there in the answer. 5 will go into 24 times because 4 times 5 is 20, and we can stop. So the decimal for 2/5 is 0.4. So we're going to write that down. What about 17%? So 17% as a decimal. Or remember, to change a percent to a decimal, we find the decimal. It's a whole number, so it's going to be right here after the number 17. And then remember, we hop to the left twice. So we go back to the left. And so as a decimal, this is going to be 0.17. Notice how I'm lining this up as I go when I change them all into decimals. So 2/5 is 0.4, 17% is 0.17, and I'm lining the decimal up with it. And then the last one is 0.7. Well, how do I write 0.7 as a decimal? Well, it's already a decimal, 0.7. And so now notice I have a similar list of numbers where I can compare them. Now, this one has 2 decimals and these both only have 1, so I'm going to add a couple of zeros so I can compare a little easier. Now we compare. Zeros don't tell us anything. Remember, we're going greatest to least here, so don't get backwards and say I'm looking for the least number. Think I'm looking for the greatest. Well, out of the second set of numbers, which one's the greatest? So that would be the 7. And so we could either say, hey, this is the greatest, or this is number 1. And I could say, I can also compare here, since these are not the same, this one's the 7, so it's greatest. Well, which one's the next greatest? Well, the 4 comes next, so this is going to be the middle number, or my second, and then the last is the smallest. So this is the least, or this is going to be number 3 in my order, because 7 is greater than 4 is greater than 1. So we really don't even need these last numbers here. We could actually just compare them using that the 10th place, the second set of numbers. And so when I write my final answer, I want to write it back in its original form. So the first one, the greatest, was 0.70, but notice in the original problem, it was just 0.7. So I'm going to put 0.7 should come first. Then my second one was 0.4, but notice that was actually 2/5, right? So 2/5 is going to be my second, and then 17%, or 0.7, 1700ths or 17% is going to be my next. So this is your final answer, and if you're given multiple choice, that's what that's going to look like. So big reminders here. Make sure that you pay attention least to greatest or greatest to least, which order you're putting them in. We want to make sure we're writing them all in the same language, so we're going to be changing everything into decimals in order to compare them. So I'm going to give you another one, and I want you to try this one on your own. Maybe pause the video and see what you think. So let's try 83%. Let's try 3/8 and 0.833. So I'll give you a second. Go ahead and pause the video. Try this one on your own, and we will go over the answer in just a second. All right, hopefully you've had time to pause the video and change all of these to decimals. So I'm just going to make my little list here. of changing 83% into a decimal, changing 3/8 into a decimal, and changing 0.833 into a decimal. Well, that's already a decimal, so I know I can write this one out. 0.833 is already a decimal. My 83%, of course, is going to hop over twice, so that's going to be 0.83, and then 3/8 is really the biggest one that I have to be concerned about. If you don't have 3/8 memorized, if you do have it memorized, awesome, write it down. If you don't, we're going to have to do a little bit of division. So 3 goes on the inside, 8 goes on the outside, 8 goes into 3 0 times, so I have to add a 0, decimal and a 0, bring the decimal up. 8 goes into 30, if you think about your multiplication facts, it goes in 3 times, because 3 times 8 is 24. That's as close as we can get to 30. Subtract 30 minus 24 if you have to borrow. 10 minus 4 is 6. 2 minus 2 is 0. So I'm going to have to add another 0, bring it down. 8 goes into 60. That would be 7 times, because 7 times 8 is 56. Subtract. If we have to borrow again, 10 minus 6 gives us 4. 5 minus 5 is 0. Still not a 0 here, so we have to add another 0, bring it down. And 8 goes into 40. Oops, guess you need to be able to see that. 8 goes into 40 5 times, and that's even. 5 times 8 is 40. It's really helpful to know your multiplication facts here, folks. So that does give us a 0, and we know when we get a 0 down at the bottom, we can stop. So as a decimal, 3/8 is 0.375. Now, make sure everything's lined up over here. Notice everything here has 3 decimal places, except for this one. So I'm going to add my 0 here. So these are the ones that I'm comparing. And remember, oh, I didn't even write down. We're comparing, oh, I guess when you tried to pause the video, it was really hard for you to put this in order, right? Let's do these from least to greatest. Sorry about that. I didn't tell you which order to put them in. If you did greatest to least, awesome. So least to greatest. And let's look for the least. So the least number is here, because these are zeros, but here's a 3. Now these are both 8s, so I can't compare them. I'm going to look at the second number, though. Second number here is a 3, second number here is a 3. That doesn't help me, so I have to look at this last number. 0 is less than 3, so this one's going to come second or be my middle, and this one's going to be greatest. So in order, you should have 83%. No, I'm sorry. You should have 3/8 as the least. You should have 83% as the middle and 0.833 as your greatest. That is your final answer. Sorry about not giving you that instruction. That probably was a really hard example to do on your own then, since you didn't have least to greatest. Maybe you still got these, hopefully you still got these conversions made and got them all written in the same language anyway. All right, last thing we're going to do for this particular topic, so if you'll flip to maybe the next page, is we're just going to do some basic comparing. So remember, when you compare numbers, again, we want them in the same language. And it's also going to be good to be reminded that this symbol right here is less than. It looks very much like an L. This symbol is greater than. It looks like a backwards L. And also, of course, this is equal. Right, so we're going to be given just a few examples, and we're going to compare them accordingly. So example number 1 for this, let's compare 0.14 compared to 1/4. And we want to know, is this less than, is this greater than, or is this equal? And so again, the first thing we want to do is put them in the same language. This is already a decimal. Awesome. This is not a decimal yet. So 1/4, if you have that memorized, awesome. If you do not, you'll have to do a little bit of division off to the side. 4 will not go into 1. Add the decimal 0. 4 will go into 10 twice, because 2 times 4 is 8. 10 minus 8 is 2. Bring down another 0. 4 goes into 25 times. And 1/4, 1/4 should definitely make you think 0.25. That's a quarter. And so now we have both of these decimals, so we're comparing 0.14 to 0.25, and you can line them up if you like. Lining them up helps you compare the place value a little better. So remember, we're trying to decide which is this first one, is it less than, is it greater than? And so when we compare them, we find that they both have zeros, but we find that the 1 is definitely less than the 2, which means I'm going to use the less than symbol. Now, you probably were also taught maybe in elementary school to make sure that the mouth was eating the bigger number. And in this case, we find that the 0.25 is the bigger number. So let's try a couple more of these, and then you'll be ready to go and practice. So example number 2, example number 3. Let's try 1/3 compared to 1/6. And let's try 15% compared to 3/5. All right. So notice for this one, we actually have two fractions. So one way is to change them both into decimals. Actually, though, if you have two fractions, you may remember from elementary school something called the butterfly method. And so if you actually cross multiply with using the butterfly method, it's a great way of comparing two fractions. And so let me just remind you of the butterfly method. 1 times 6 gives me 6. I'm going to put my answer up there at the top of the butterfly. 3 times 1 gives me the example of 3. And then I compare these two numbers. So 6 is greater than 3. And so that means my symbol is going to be greater than. It should be eating the 6. So you can use the butterfly method. Let's just do another one real quick just to remind you of the butterfly method. 2/5 compared to 1/7. And we want to compare that. So again, butterfly method is if you have two fractions, 5 times 1 gives me 5, and 2 times 7 gives me 14. And again, you would compare these two numbers. So that's another greater than symbol that way. So if you have two fractions, you can compare them that way. Down here we have a percent and a fraction. And so again, we want to change them both into the same form. 15%, if I move my decimal back, gives me 0.15. And then 3/5, if you don't have that memorized already, 5 goes into 3 0 times, add a 0. 5 goes into 30 6 times because 6 times 5 is 30. So 0.6, you can line them up and compare them. 0.15, 0.6, add a 0 to make it even to compare. Zeros don't tell me anything. The 1 is less than the 6, and so this symbol is going to go in the less than because, again, 6 would be bigger. The 6 would be bigger in this place value, and so this is the bigger of the numbers. And so that gives you a place to start with some practice of comparing and ordering. Again, remember, we've learned all of these languages now. We've learned how to translate between the languages, fraction to decimal, decimal to percent, percent back to decimal, decimal back to fraction, so that we can now, when we're ordering things, we can now make everything decimals so that we're able to compare them a little easier. So you're going to do this when you're practicing. Make sure you email me if you have any questions.